Hi, good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. My name is Satya Ramesh, and I will be the host for you for the next 1 hour. And we have Markus today to do a session on model your data like a star in Power BI. Before we start, a quick introduction about who we are and what we do. So we are Data Platform Geeks. Without being formed as a formal community long back in 2004, we started as a small community in the city of Calcutta in India with 7 people. If you can look at the picture there, it was a small picture where Amit is standing there with few group of people. I'm not sure which technology they were discussing that time. It was a SQL related only. I'm sure about that. And then from there onwards, we have grown we have grown to many big community. We have grown a big community from there onwards. And in the year 2010, we have formally formed a community called SQLServerGeeks.com. And then with the brand of SQL Server Geeks, in the year 2015, we started first Asia SQL conference in the year 2015, and we called that as SQL Server Geeks Annual Summit 2015. And then we continued in 2016 at the same name, SQL Server Geeks Annual Summit 2016. And in the year 2017, we have also rebranded our community work because SQL Server has grown beyond its own capabilities. So we have formed a community called dataplatformgeeks.com. And from that time onwards, we have rebranded SQL Server Geeks Annual Summit to Data Platform Summit. And then we had done 2017, 2018, 2019, and from 2020 onwards, because of the pandemic, we have gone online, and that becomes Data Platform Virtual Summit 2020. And we have done 2020, 2021, and this year again, we are doing Virtual Summit in the year 2022. So from this is the last in-person event we had done, in-person conference in the year 2019. After that, it's all virtual. We really cherish this pick. This was happened in the year 2019 in Bangalore, in Radisson Blu Hotel, where Gail Shepherd, who was a corporate vice president for data platform that time, came down to Bangalore to deliver a keynote. You can also see a lot of Microsoft experts and community experts there who are delivering sessions that year. So from this small group of people to this big people, Data Platform Geeks and SQL Server Geeks have improved a lot and grown a lot. So we really cherish these pictures. So this is where we compare from 2004 to 2022. And a lot of people are joining in. And in the year 2019, these many people joined us from these many countries, speakers and attendees joined from these many countries. And last year, in the year 2021, we have a lot of good participation across the world. And these are the top 20 countries where we have got the participation. We have close to 100 countries last year, but these are the top 20 countries where we have got the participation from for Data Platform Virtual Summit. And yes, good news is there. Data Platform Virtual Summit 2022 is announced, and the bigger news is it is free. It is free for everyone. You can join from anywhere, and you can inform your friends, colleagues, and you can just register for free, and you can able to attend close to 200 sessions from 200 plus speakers. It will happen in multiple editions from September 19 to September 23. And we have also announced pre-cons, which are 8 hours virtual training classes. Right now, we have 12 pre-cons announced. This is a quick list of pre-cons that we have announced. So we have Dave doing a session on analytics at scale with Power BI and Azure Synapse Analytics. And we have Jason Brimhall doing a session on extended events. We have Milos doing a 8-hour training on Query Store Deep Dive. We have Thomas doing a 8-hour training on Spark for data engineers. And our special speakers for today, Markus is doing an 8-hour class on data modeling in Power BI. And we have Nicola, who is doing Power BI performance. We have Dezan, who is doing advanced analytics with Transact SQL. We have Dennis, who is doing ETL in the cloud. And we have a few more training classes on SQL Server performance by Guy Glanster and Dennis Regic. We have a special class on PowerShell from Ben Miller. Friends, there are a lot of classes. And there is a special discount code only for you. If you attend today's webinar, use 60 still it. That discount code will give you 60% off on the current pricing. So that is the best you can get. And along with that, friends, you can, with that pricing, you can get to attend live. And the good thing is, thanks to our speakers again, you can also get recordings for free for streaming for the next 12 months. So this is the only conference who is also giving you the streaming access for the training class recordings, friends. Please go and grab it. 60 still it. That you need to take care. And today's speaker, our Markus, what happened? Yeah, he's doing a full day training on 8-hour training on data modeling in Power BI. So you can go ahead and book that class as well, because all of you are Power BI audience, I suppose. And this is the current pricing, friends, which is very, very less. It is after 50% discount. Then if you use 60% discount code, you will get it around $200. So within $200, you will get to learn from the world's best, and you also get to have recordings for the next 12 months. And as I was telling earlier, Data Platform Summit this year is happening in multiple editions. We are doing 5 editions this year, from September 19 to September 23rd. So we will start from ANZ edition, then APAC edition, India edition, EMEA edition, and Americas edition. So 5 editions. You just need to register once, and you can attend all editions or any edition that you would like to attend. And if you want to have only few sessions in different time zones, yes, you can do anything you want to do. You can do only one single registration is required. And this time, thanks for all the speakers in supporting our diversity efforts. Content will be delivered in 14 languages in this year's Data Platform Summit. We have content in Portuguese, Spanish, German, Serbian, Russian, Chinese, etc. So other than English, we have also content from other languages as well. Thanks to all our speakers who agreed to support us in improving our language diversity. And we have a special track on SQL Server 2022 from the Microsoft experts who make SQL Server. So we have directly product people coming in and explain what's new and what are the capabilities of SQL Server 2022. We are running a special track on that. We have a special track for students also who are into the technology, like in level 101 sessions, like introduction to Power BI, introduction to SQL Server, etc. for the students as well. And as usual, content is king. We believe in the content. So right now, close to 200 sessions are already announced. You can go to dataplatformvirtualsummit.com and you can browse all the sessions that are there that will be delivered as part of this summit, all for free, friends. Please remember that. And technology coverage also, you can go ahead and look out. And if you wish to participate in the Knowledge Partner Program, if your company wish to participate in Knowledge Partner Program, please write to kp@dataplatformgeeks.com, or else you can visit dataplatformvirtualsummit.com. All the details are there. From there, you can reach out. So, friends, all set. You know everything about Data Platform Virtual Summit, and you know something about pre-cons as well. So go and evaluate. And for Summit, you can just go and register. You can also spread the word in Twitter, LinkedIn, and within your organizations as well, because it's free for everyone to join from anywhere in the world. So bookings are open. Please go ahead. And special thanks to Microsoft for supporting us in our community efforts, be it SQL Server Geeks, be it Data Platform Geeks, or Data Platform Summit. So these are the social channels, friends. Most of you must be knowing them. So with this, all the housekeeping announcements you all know by now, because the pandemic taught us few more things that we don't know a few years back. So please keep your headphones, and if you have any questions, please use Q&A panel. Don't put your question in the chat window. So feedback, I'll come to that later. So with this, friends, I'll hand it over to Markus. Markus, over to you.
Thank you very much. Yeah, that's a quite impressive introduction to DPS. Also, the 7 people up to whatever, how many people it was. Very fun story to share, and impressive what you did so far with this community. Let me share my screen if I can find the right button here. Yes, sharing screen again. And then we jump over to my, where is it? Now it's gone, of course.
Yes.
over to
It
my,
is visible. Screen is visible.
yes, and I have to jump over to my virtual machine. Here we go. So you should see now my slide deck, model your data like a star. Can you
Yes.
confirm? Very good, very good. Yeah, so welcome to Model Your Data Like a Star, and the pun is intended. So this is about that you can be a star in data modeling, but also that your data model should look like it's a star schema. And whatever this is, I will explain in the rest of this 60-minute talk. My name is Markus, and I work with data models. And when I tell people that I work with models, they have sometimes different things in mind. So they think I work with beautiful people, but instead I work with beautiful data, or at least hopefully after I shaped it right, it looks beautifully, because data in its natural habitat is never clean and beautiful, right? We always have to clean it up, and this can be kind of an effort. Why is data modeling so important? Because Power BI desktop is first a self-service BI tool, and that means that it does a lot of things towards the end user. The tool is not so much for the IT folks, but for people with domain knowledge who have domain problems they have to solve with the tool, and they can solve it with the Power BI desktop. And it's very important that you're aware about the Power BI desktop is a model-driven tool. That means it's very, very important that you shape a data model. Other tools, like if you think about reporting services, Report Builder, this is not a model-driven tool. This is a tool which likes to have one query where you put all the columns from your data source just as columns of one query. It's called the data set in Power in reporting services, right? And then you take from there what you need. In Power BI Desktop is totally different. So it's model driven, and that's why it's important that you're aware of that there is a model and that you have control over the model and think about the model and get it right. Power BI Desktop, as it is an end user tool, tries to make this process as easy as possible by doing educated guesses. But of course, a tool not having any domain knowledge about the problems you have to solve can also only do so much of educated guesses. So they make it comfortable to use, but sometimes it's not the right decisions the tool makes for you. So you always have to check out what the model did. For example, what kind of relationships were created, what kind of cardinality was created, and so on and so forth. It's always the right relationship active, or are there any inactive relationships? And they have to think about. So this is very, very important. And from my perspective, this is the hard part, and it's definitely the most underestimated part of your things you have to do when you work with Power BI Desktop. Of course, Microsoft is not selling it that way. It's like showing you how easy it is, and it is easy to use. But there can be some traps, and that's what we talk about in this talk, what I've prepared it. So for the agenda, we talk about relationships, and I mean here relationships in your data, not your private relationships. I will not talk about them. We talk about the term, which is a really weird term, at least for me. English is a second language, and normalizing is really weird. This is a term from IT, from database technology. And for business intelligence, we do then denormalize things. This is I don't like the term, to be honest, but this is how it is. We'll talk about it because it's very important to understand what's behind the term. It's not so important that you understand the term or remember the term, but this task is really important, what's considered as denormalizing. And then a very, very important dimension in your data model, or in most of your data models, will be the date, because almost all the data we have to work with, there only might be rare exclusions. And I can't even think about a data model I built where there were no date relationship. There's always a relationship to date, because we want to know when something happened for most of the cases. So that's what we will talk last time. So 3 things for the remainder of the 60 minutes. Start with the relationships. So relationships, if you look at them, look like foreign key constraints. Depending on if you worked with databases so far, you might have an entity relationship diagram in mind where you have different tables and they have then lines between those tables, and those relationships in the relational database are foreign key and foreign key constraints. But the relationship in Power BI only like them because they look like them, but they're not constrained. So in the relational database, we use the constraints to avoid that you insert a row in the sales table, for example, referring to a customer which does not exist in the customer data, the customer table. This is what the constraint limits you. You can only insert rows in the sales table for customers you already have in the customer table, which is a good thing because it increases your data quality. Power BI does not take any limitations on your data. You can load sales rows for customer keys, which are not available in the customer table. Power BI doesn't care about that. Power BI works the other way around. It uses those relationships to filter your data. That means if I put a filter on the customer table, for example, only on my customers from India, it will then pass a filter on the sales table, which limits then the sales only to customers residing in India. So then I get the sales I had with Indian customers. So this is the other way around. It's quite intuitive, but you have to think about it once, I guess. The filter can have two modes. Either it's a single directed filter or it's a bidirectional filter, so going in both directions. The standard, and that's what you should aim for, is only having single directed filters. That means that if I put a filter on the customer table, on Indian customers, for example, on the country of India, then will limit the rows available in the sales table. But usually I do not want to get the filter the other way around. If I filter something, for example, the date also on the sales table, it will not filter the customers for only this customers which have a sale in a certain year. This would you could achieve with a bidirectional filter. So if I put a filter on my year and then therefore limiting my sales rows available, then this filter will also go back to the customer table in a bidirectional mode. But you should avoid this because you're paying a big penalty on this because it makes your model first slow. And second, you might end up with a situation where your model is not ambiguous, where your model is ambiguous. So that you have like a circle in your data model that the filter transfers to a lot of tables and then coming back to the first table. And Power BI does not allow you to have ambiguous models. So you would end up in a problem because then you have to change somehow your model to achieve what you want to see, but lose the bidirectional filters. So if you're interested in this cross filter thing, you should not solve it with bidirectional filters, but with putting on filters on your report on those tables, which is not part of this talk today. And the cardinality is also very important. We can have a one-to-many relationship, a one-to-one or a many-to-many relationship. And a one-to-many relationship, this would be like one customer can have hopefully many sales, many rows in the sales table. Maybe there's also one customer which is quite new who only has one row in the sales table or not even a row in the sales table because the customer just registered, very, very new. Again, this is the default and this is what you should aim for. You should avoid the other ones, the one-to-one and the many-to-many. The one-to-one relationship would be if you have one row in one table and another table, exactly one row again. Usually would model this as one single table. The only way or the only reason I would model it as different tables is because maybe it's two different sources, or you want to have different schedules, different schedules of refreshes for different portions of your data. And the many-to-many sounds really attractive in some situations, but again, you should avoid it because you're paying a penalty performance-wise, and that would be that there's no primary key on either of those tables. So the situation could happen because your customer table, for example, there's one customer in there with the same customer key. There's two rows in the customer table, and then you would end up with a many-to-many relationship. Power BI would not allow to create a one-to-many relationship because the one side has to be distinct. And if you have a situation like that, please do not keep the many-to-many relationship, but solve the issue you're having, namely that you have a customer key in the customer table which is not distinct, which is not unique, and you should not have a situation like that. For the cardinality, the one also includes like a zero, and also the many includes zero, as I already pointed out. There might be a customer which not having yet a relationship or a row in the sales table, or just one row there. And this is how we jump in the first demo here. So different relationships. So the first thing what we're having here is a one-to-many relationship. And no, this is not a model view. This is a report I created, which is mimicking the model view. So it's just a report with two different tables from a model. So I have a transaction table, I have an account table, and then we can see that there's a one-to-many relationship. Again, this is just an image, but makes it easy for me to explain how my model looks like, because now we also see data here. And the account table is on the one side, the transaction table is on the many sides. So one account could have several transactions. As we can see here, there's account ID number 11. We can see there's two rows in there. So this is a classical one-to-many relationship. And this triangle here in the middle between the star and the one, that means the filter direction. So the flat side pointing towards the account table and the pointy side pointing towards the transaction table, which means that the filter from the account table, if I put a filter on the account table, it will also put the filter on the transaction table, but not the other way around. So if I click here on bill, for example, then we can see that the transaction table is now limited to the two rows where we have a relationship to the account with account ID number 11. If I, on the other hand, put a filter on the account on the transaction table here, nothing happens on the account table because the filter is not going backwards. It's only going in one direction. And this is what we want to have. So your goal is only having one-to-many relationships with a single directed filter from the one side to the many side. There is exclusions, of course. There's, as always, there might be situations where you cannot model it like that, but then please go inside yourself, think about it, and talk to your peers, to your colleagues, and find out if it's really the only way or there's a way around. Because that's what we're gonna going for, is having a relationship like that, because it's faster. And Power BI as a model is optimized for models having one-to-many relationship. That means you can load any model into Power BI. It will work, but you will have to pay a performance penalty, and maybe also your DAX calculations will be really, really complicated if you stick to other models, like having a third normal form. Like you just take the tables from your source system and load it into Power BI. Of course, you can do that, but you will pay a penalty for that. And the problem is, when you start with everything is fast anyways, because if the tables are small, or if the test or demo data is small, not many rows, everything will be fast anyways. But as soon as you transfer to production and having more data, or over the time, over the years, your data model increases in terms of size of rows in the tables, then first you will face the performance penalty. And then it might be too late, because changing the model, changing how your tables look like, also breaks your reports. So every report you created is then broken. So you have to start from the beginning, not only with the model, but also with the report. So this is a really high penalty you're also paying here on this front, because you have to recreate your reports, and nobody wants to recreate reports, right? So that's a one-to-many relationship. For the one-to-one relationship, I would have an example here for the customer detail. So there's a one-to-one relationship, and there's the filter by default is always going from the one side to the other side. Now we have two one sides. This means that I have a bidirectional filter here. This is okay for the one-to-one, we cannot change it. That means if I put a filter on the customer, it's also filtering the customer details. Remove the filter, and again, put a filter on the customer detail, will also filter the customer table here. One thing I have to point out here again. So if I click, for example, on the account table, I told you that on the transaction table, the account table is not filtered, nothing changes here, but everybody can see that something happens up in my report up there, right? If I put a filter on my account on the transaction table, I just filtered my report on this. And this makes it sometimes hard for me to explain what's happening in here, because I tell you, no, there's no filter going back to the account table, as we can see here. But Power BI has multiple ways of applying filters. And there's also a filtering known as cross filter, which means that between visuals, so I have a visual here, because this is not a model view, this is a report, right? So I have a visual here, I have a visual here, and by default, the visuals will communicate with each other and putting filters on each other. So if I filter something here, it filters up my report table, my matrix or my table up there, but this has nothing to do with the model. And I know it's hard for beginners. This might be hard to grasp, that there's different ways of filtering, and maybe this is confusing you. Please just trust me here. The filter I put in here does not change anything over the model. It's just filtering directly from this visual to the other visual. And for the many-to-many relationship, there's different ways. For example, we have this many-to-many relationship here, which is not really many-to-many relationship because transactions and count customers doesn't really have to do, something to do with each other. But we see that the account also has a relationship to the account customer with a one-to-many relationship. And as the filter again is a one-to-many, the cardinality is again a one-to-many relationship here with the filter going from account to customer. This means if I choose one of my accounts here, it will filter transaction, it will filter the account customer table. But the other way, if I filter a transaction, as it will not filter my account table, of course, it does not filter my account customer. And this also means for the other way, so if I filter something in here, it will not filter my account table, but and therefore it will not filter the transaction. So the filter is not going from transaction to account customer or the other way around. With my default behavior of a one-to-many relationship with a single directed filter, which we want to have like that. So let's jump back to my slide deck. So denormalizing. What is denormalizing? Before we can talk about denormalizing, we have to talk about normalizing. Again, a term which I don't really like. So normalizing is a term was introduced by Edgar F. Cott, C-O-D-D. If you never heard about Edgar F. Cott, he is the inventor, the mastermind, the godfather behind relational databases. So if you ever work with SQL Server or DB2 or Teradata or Oracle, those are relational databases. And they were invented by Edgar F. Cott, and he also invented this term normalizing because there were a lot of different databases available back in 1970 when he came up with this idea of relational databases. And for BI solutions, we take back some of this normalization. Let's see what I'm talking about here. So the naive way of doing things would be a single table. So if for example, you ask me, Markus, please give me a table containing all the products, the subcategory and the category they're assigned to with their sales amount for a certain year. Then I would give you an Excel spreadsheet, a table with 4 columns, right? The product, the subcategory, the category, and the sales amount. And this is a single table, which is easy to read, which is easy to handle somehow, but we face the problem of having redundant data, because if there's a category, product category on this list with more than one product, then the name of the product category appears several times on this list. And this comes with problems. Because if I want to change the name of one of my categories, I have to make sure that I change it on all the occasions. Because I will only change one of them, I end up maybe with bike and bikes, which is still in the real world, it's the same category. But on my list of my reports, I suddenly get 2 different writings of the same thing, and I get 2 different lines which do not show the same subtotal or something like that. So this is a problem. The other problem is if I have only, for example, one product left in a product category and I want to delete the product on my list, I would also, if I don't take care about it, I would also delete the last product category. So I'm losing the information that I once had this product category. And the same is for inserting. If I want to insert a new product category where I currently don't have any product, how would I insert this to the list? Like leave the name of the product empty and so there's problems here. And solving these problems is easy with a normalized schema, which Edgar F. Cott invented back in 1970, which is a long time, right? And those databases are still around. So the goal, the unified goal of normalizing a schema, even I don't like the name because I mean, what's normal? What's normalized? I don't think this really makes too much sense. But yeah, Edgar F. Cott invented this term. So the goal is to avoid redundancy. And 3NF means third normal form. So there's different categories, first, second, third. There's also Boyce-Codd normal form, fourth, fifth, sixth, I believe, which is really, really academic. So for most of the schemas you will face if you connect to an application database, and there's some data engineers working on that, most probably they made the schema in a normalized form, which means third normal form. That's the default. So there you avoid also redundancy. So the table we just talked about, the Excel spreadsheet with those 4 columns, you would split it then into different tables. So you would have, for example, you would have one table only containing the sales amount with the reference to the product to which the sales amount were happening. So you have a product key, be it the name of the product. And then you have a table with all the products, the unique list of the products, only with the reference to the subcategory. And then you have another table with the distinct subcategories in your system with a reference to product categories. And then you end up with product categories. And again, it's just a distinct list of the product categories. With the advantage, if I want to change the name of a product category, I just change the one occurrence of this product category. So it cannot be that I suddenly, by changing something, end up with bike and bikes. Because either I change the row to bikes or I change to bike. So there's no way of having a problem here. If I want to introduce a new product category, I just insert it into the table of the product categories. Done. Maybe there's no reference now from the subcategories and the products to this new product category, but I just inserted this new product category without any problem. And the same is if I want to delete the product or a product subcategory, and if it's the last element within the product category, yeah, no problem at all. I just delete the row in the product or the subcategory table, not touching the product category table. So I still keep the product category even if I just dropped the last products from this category. So this is the idea. And this is very good for applications because applications, they read, of course, from the data, but mostly they add things, they change things. So if think about any application you have in mind, you have like customers, you might have products, you might have services. So you're changing and maintaining those tables there. And that's why applications want to avoid those redundancies. The backdraft of the normal schema is it's really hard to query because imagine now we have like instead of the single table approach, we have now 4 tables. If I want to see now get my end result back, I have now to query from my sales table, join it with the product table, join it with the product category, subcategory table, join it with the product category table, having the join keys. So there's a lot of writing. The SQL statement is really, really long, a lot of joins. So that means that I can make errors in there. The more joins I have, the more risk is there that I write the join operation, the on operation wrong, for example. And also for the database, it's much more work because also the database has to find one table, a row in this table, find the corresponding a row in the joint table. So the query will also be slow. And this is why this idea of denormalizing the schema came up. But we reintroduce important some redundancy. So the denormalized schema does not mean that we undo all the normalizing, going back to the single table. No. A denormalized schema has some normalizing in it, but other tables are not normalized. So the fact tables, to make it clear here, the fact tables are still fully normalized. They are in third normal form. The dimension tables are not normalized. So they have the single table approach, so to speak. So everything which is in relation to one dimension is in this one dimension table. So dimensions should not join other tables or reference other tables again. So the question is how we can find out what's effect, what's a dimension table, right? And then there's also the Snowflake schema we will talk in a minute about. So single table would be a really wide table. In this view, we get all the column names underneath each other, but this would be that I have one table, effect reseller sales table, and I made all the attributes I'm interested in as part of this effect result sales table. So everything from my team date table, the quarter, the semester, I just put it in one single table. So it's a really wide table. And for Power BI, you should avoid this. There's other tools on the market, like I think Tableau or other tools. You have to come up with a single table, not with Power BI. So this is a real distinguished thing. And you might think maybe it's harder than in Power BI, but also Power BI with the modeling approach gives us the ability to model complicated things, which is hard to do or impossible to do in, for example, Tableau. I'm not a Tableau expert, but if you have a single table there, you will end up with other problems. For example, if you want to include the budget, which is in a different crane, it's hard to model, I guess, in Tableau. So star and snowflake schema means that I distinguish between dimensions and facts. So what's a dimension table? Again, it's a term, you can like it or not, but a dimension is something which tells us how, what, when, where, who, why something happened. And it gives the scope of the model. So we want to usually, if you think about a report and you think about things you put on the rows or on the columns, or you think about slices or filters in your report, those are dimensions because we filter and group on dimensions. They're relatively small. I mean, relatively, it's also relative, right? So for one of my customers, we worked with end users, and when I left this project, I left this employer, then we had 200 million rows in the user tables. They can be big tables, but compared to the fact tables, they're comparably small. They're always on the one side because there's one date, there's one customer, there's one sales territory, and this is then referenced multiple times by the facts. And usually, or for sure, you have a primary key in there. So primary key means this is a unique identifier. Usually from data type perspective, should not be unique identifier. It should be an integer, just number. It's just a new customer that just gets a new number here. The number doesn't have any meaning, and you get all sorts of data types in this table, and the table can be really, really wide. Because if there's something we want to filter and group on, we put it in dimension. So think about the date dimension. We have a year there, financial year, calendar year, the quarter, the month, maybe combinations of the year and the month in different ways, like year-month number or the month number abbreviated, whatever. So those tables can be really, really wide. But as they're relatively small, it's no problem at all. On the other hand, we have those fact tables, and fact tables, I think the most important thing is that it contains real world events. So something happens, a transaction, some detailed, we did a measurement, and then we tracked it in this fact table. And they are the meat of the model because we count events there. So we want to know how many people went through this store, for example, because we have an IoT device there, which every time somebody comes in, we count this. Or it can be really aggregating things, like think about a supermarket cashier. When you put your goods on this band, then the cashier just puts it through the scanner, right? And every time it's made beep, you have a row in the fact table for the supermarket. So this is real world events, and they're connected to the dimensions. So every time it makes beep, we know what product at which point in time, in which cashier, in which supermarket, in which territory was sold, what was like a special offer on that. If the customer has a customer card, we also can collect information about the customer, who bought which thing together with other things, and so on and so forth. So this is the meat of our model, and they're relatively big because one customer on one day in one territory in one cashier, we might have several facts, several transactions in there. They're also on the many side because one customer has many transactions, hopefully. And usually those facts, I mean, there might be exclusions, but usually they only have the foreign keys to the dimensions, which should be integers, and only numeric columns. There might be exclusions, but this typically for the fact tables, because we have like a price, we have a quantity, maybe we have calculated the price times quantity, we have a sales amount. Those are things we're collecting in the fact table. And hopefully it looks easy like that. Sometimes it's really, really hard to model it and really distinguish between the dimensions and facts. There might be cases where it's hard to decide, is this a fact, is this a dimension, is this attribute a dimension or a fact, where should I put it in a dimension table or fact table, like a price? Should I put it like in the fact, or should I just connect it to the product? But what if the price then changes? Then I need some tracking in the dimension, slowly change the dimension, which makes it then harder to load the dimension table. So I might decide to put it in the fact table. So there's a gray area for some certain things. So expect, if you model this, expect that it's not just easy to go. Sometimes it's really hard, and you have to do discussions with those people who are the domain experts, who know what these real world events mean, so we can then try out to make the best data model out of that. So a star schema would mean that we have a fact table and then we have dimension tables around. You see the dim product. I mean, The real world model, I would not name it dim date. I would just call it date, because dim date is confusing for the end users. They don't care about if this is dimension or effect. So think about this just a date table, and this would just affect result, say without the large, but with a blank in there in the sales territory of the product. And those are the dimensions. So they're on the one side, as you can see here, the dimensions, and the effect table is on the many side here in between. And we only have one-to-many relationships, and we have only single directed fields in here. That's a star schema. And again, a term not invented by Edgar F. Cott, but a term invented by Ralph Kimball. They came up also with, as I think, sometimes weird explanations of weird terms. So if with a little bit of fantasy, you could see like a three-pointed star in here. Yes, I know. It's really hard to see. But as opposed for the star schema, Snowflake schema, this would be then that the points of the star could split, not all of them necessarily, but maybe some of them. Then we call it a snowflake schema. And the difference is here that the dimension here, one of the dimensions, is still normalized. So we have the category, the subcategory, and the product table in different tables. And if you can avoid having a snowflake schema, it's a good idea, because snowflake schema tends to be slower, because now the filter on the category has first to filter the subcategory, then the product, and first then it can filter the sales, the reseller sales. While if I have the product category name already in the team product table, I just put a filter on this table and it's directly going to the effect table. That's much easier. And also less confusing, because think about that Power BI and everything we're talking about today also applies to analysis services tabular. So it's the same thing behind the scenes. Power BI desktop, the data model in Power BI desktop, and the data model in analysis services tabular is the very, very same. So this also applies there. So if people connect to this data model, then it's much easier for them to just find the product table and then see all the attributes related to the product, as opposed to having to know where a certain attribute is stored in the product or the subcategory or the category. So it's also the UI we're changing and making up with the data model here. So if I compare those two approaches, the star schema and the Snowflake schema clearly has more tables. So we have the product, category, subcategory, and category table. And this means it takes longer to load because we have to load more tables. It also makes filtering slower, as I already pointed out, because then the filter has to walk through several tables before it ends up in the effect table. And it makes the field pane less intuitive, because the folders, the tables are folder names, right? And then people have to remember where they could find some attributes related to the product. And if you're working with hierarchies, I mean, hierarchies are not that important from data model perspective in tabular. It was very important in multidimensional models, but not in tabular models. But it's a convenient thing that people just can drag the calendar hierarchy or the product hierarchy into the report, and just with one drag and drop or with one click on the checkbox, they add the category, the subcategory, and the product name to the report. This is only possible if you have all the elements in just one table. So if you want to build hierarchies, you have to denormalize your dimensions anyways. I just did a quick test here, so this is not very scientific, but it still surprised me. So if you think about a single table, then we have one table, this wide table where I loaded everything into it. And the star schema would have four tables: the effect table in the middle, and then with the territory, the date dimension, and the product dimension. And for the snowflake schema, we would also have the product dimension split up into subcategory and category. And what surprised me was the size of the thing, because we know, I mean, Power BI, Vertiback engine, like the column store index in SQL, in the SQL database, is really good compressing everything. But with the single table approach, it was almost 3 times as big as the star schema, Snowflake schema. This came as a surprise. And if you think about, one thing is the storage cost you're having, or like the memory pressure you're having on your laptop for Power BI, or the memory pressure on your server where you have analysis services tabular running. But the other thing is that, of course, even if it's in memory, it means we have to scan almost 3 times the size of memory. And of course, this will take 3 times the size of scanning only a third of memory. So even if everything is compressed and in memory, we see or I could see here in this example a big difference in the model size, and of course this also will make a difference in most of the queries and the response of your report. It's also good to know that relationships are stored in the model. So if I create a relationship, it increases the size of my model because Power BI or Analysis Services Tabula is storing like the keys of one table and the keys of the other table in one object. So it's like an index, makes it easier to find all corresponding rows from the other table by just accessing this index. So of course, in the single table, we don't have any relationship, but this is much bigger. So the 600 or 700 keys for the star Snowflake schema doesn't really count. So the neglectable for this 84 megabytes. And of course, the Snowflake schema has 6 tables, so two relationships more. So we have a little bit more of the relationships, which doesn't really make a big difference. So how can we create a star schema? How can we create a Snowflake schema? And the answer, at least for self-service, is Power Query. So use Power Query not only to filter the data, to choose friendly names and choose the appropriate data types, but also to flatten your dimension. If you're connecting Power Query to your relational database, it will even offer you to expand the reference table. So use that. If you're working with a relational database, of course, at least make views because you should never access to a database without views. So always build views and flatten your dimension in the view. So do the join in the view. So I have a product view called product, and there you select from your product table, but also join to the subcategory and the main category, the category table, and add those attributes from the subcategory in the category table to the field list of your view. And please do not flatten the facts. The facts stay normalized. The reason for that is because the facts are really, really long. We do not want to be them very wide, because every byte or bit we're adding in our fact table means that we add huge amounts of data into the model. So if you think about 1 billion rows, and we have 1 byte added to the fact table, that means it's 1 gigabyte of data. So 1 billion bytes of data is 1 gigabyte. So every byte we add to this table with 1 billion rows, we add 1 gigabyte of memory. And of course, we should avoid this. For the dimensions, not a big issue, because if you think about the data dimension, like 365 or 66 rows, for 10 years, not even 4,000 rows, I really don't care how wide this table is. It's really neglectable. And this leads me to the data dimension. And we have 12 minutes to go. Very good. So they are necessary for convenience on the one hand, because I do not want those people working with my data model to calculate like the holidays, or to calculate is it a weekday or a weekend. We just add those things to the data table. And if you're using DAX and want to use those built-in time intelligence functions, then you also need this data dimension. And mostly, or like always, that's like the shortcut here, always mark your date table as a date table. It's only necessary if you're using a date time key, which is not a date time or date of date, but the easy way is just mark it always as a date key. Then we also talk about auto date time, which is for convenience, but this should avoid it. The calendar auto function and the role playing and the multiple tables as a modeling approach. So the shortcut here, I could show you a demo, but as I only have 12 minutes left, just take the shortcut here. If you have a date table, go to the modeling ribbon, mark it as a date table, and then it will offer you all the date columns which have data type date or date time, and then you just choose it and you press OK. That's it. And it will make sure that all the time intelligence function always works, no matter what kind of key or data type you're using for the relationships between the date table and the other tables. So we jump over here. For the auto date time, this is on by default, and I urge you turn this off. You can turn this off under File, Options and Settings, and then under Current File, you have this Data Load option with the Time Intelligence option. And if you want to turn it off for the rest of the lifetime of your laptop, then please also go to the global section. There's also a data load. So there's one for the current file and one for the global option again. And there's also time intelligence, and also turn this off. The reason why I'm asking you is because this is meant for convenience for people never heard about data modeling. They build their first data model, and you already heard about the data model, right? So you're not one of those people anymore. So you know more, and therefore you should turn it off, because the consequence is the following. It does create for every column in your data model of data type date or date time, it will automatically create a date table in the back. So as you can see here, we have 1, 2, 3, 4, 5, 6 local date table, and then a grid here. And those tables are hidden, so you can't see it in Power BI. And the issue here is it's looking for all of your columns, and it for each and every column, it looks up what is the lowest or the oldest date, what is the newest date, and for all the days in between, including the 1st of January for the oldest year and the 31st of December for the newest year, it will create a table for you. So it just created one with 1,000 rows here, another for 1,000 rows here, which is like 3 years, right? Then one for 4,000 rows in here. And you see the table sizes. This can sum up. So even if you don't use the time intelligence on those columns, this is great for you. And think about when you load, for example, employee data and you have the birth dates in there, then it will create, like you have like people 60 years old, 70 years old, whatever, in your employee table, that will create a calendar, a date dimension for you for 70 years. And I'm sure you will never ever use it because you're not interested in time intelligence calculations on the birthday of your employees. So please avoid this, turn this off, and make sure that you create a date table on your own, which I will show you in a minute. And the other thing is that if you use this built-in, this auto date type, then referencing to this dimension has a certain syntax in DAX. So if you then reference to the calendar year, the month, the quarter, or the day, and by the way, it's just those 4 things. You cannot change it. If you don't need the quarter, or if you need the month in a different writing, different language or whatever, you cannot change it. You don't have any control over that. And if you add this to the report and afterwards you turn off this time auto date time, it will break the report again. It will tell you it could not find the date anymore because it's a certain syntax how it's referencing this table. So again, you're paying a penalty if you're not turning this off early enough. If you're paying turn it off later, you will pay a penalty and have to recreate some of your reports, which is waste of time, right? The other thing we should talk about, for dimensions, there can be a role-playing dimension, and for date it's very typical. So that's why I picked up and talk about that. I talk about the date dimension. So there's the possibility that you have one date table, as you can see here, the date table, and one fact table, the sales table, but you have different dates in the fact table. So if you order date in here, that's the active relationship. So yellow here, you can see this here. And there's also a second relationship, which is dotted in here. So there's a dashed line here. This means it's inactive. And this relates the date column to my ship date column. And this is how we could model this. So now we have like a simple model, only one date table, only one sales table, but 2 different relationships. And then we have this inactive relationship. And I will show you in a second how we can, I forgot again to close my demo files in here. So I should close one file, then the next will open up. So this is one way of modeling it with one date table and a sales table and having an inactive relationship. And you cannot have 2 active relationships between 2 tables. That's why one of them automatically is inactive. So why the heck would you create a relationship which is not active? And the thing is, you can activate it through DAX. So we have this function use relationship in DAX, where you can then activate the relationship. So that's the date table. I don't need this one, the marked date table. And maybe also talk about the other one. And the second one is that we could model this role playing, not with really role playing, but by adding the date table several times. So we'd add one time the date table, say order date, another time the same table with all the same data again as a ship date. As you can see here, now the model is more complicated. The model is also bigger. I mean, might be neglectable because it's just a date table. It's not even 400 rows per year. But then we don't have to use stacks for that because we can just put a filter either on the order date or on the ship date, which is not possible in here because if I both would be active, that would mean that if I put a filter on my date, Power BI would not know should it filter on the order date, should it filter on the ship date, or should we put a filter on both of them and connect it by or by and. So this is like not very clear, it's ambiguous. So that's why I'm not allowing to have more than one active relationship in here. So the role-playing thing would be that with one date table, the default behavior is about the order date. So if I filter here on different dates, it will filter the other table only on the order date, as we can also see here in this date filter. So now we have the 1st of June in here. And if I filter, for example, on the 2nd of June, then we will see that the last row will is now missing because we filter now on the date. I put only the filter on the date, but as we can see, it's only filtering by order date. The ship date is in July, and we still see those rows even if I have to put the filter in here. So how can I put also a filter on the ship date if I need to? And this is where we can use stacks. So I created a measure in here, ship quantity, and the ship quantity, I'm not sure if you ever have seen tax, but it's quite intuitive here, this formula. So we have a sum function here. So I'm summing up this from the sales table, the quantity. So I take all the quantities from the sales table, sum them up, and then I put this inside of the calculate function. The calculate function allows me to have another parameter, the second parameter, and through the second parameter, I can tell Power BI that it should change the behavior of the model, that it should add or remove filters and stuff like that. So calculate is a really, really powerful function here. And as we already have seen on the slides, the use relationship allows me to tell, please sum the quantity up, but use the relationship, the inactive relationship between the date table and the sales ship date. And with that, I can have then a list of my different dates and see then the ship quantity is only showing up in July because the ship date was in July, right? Mostly if I do something like that, I would also create an order quantity measure, just to not having a quantity and a ship quantity because this might be confusing. So I would also add an order quantity, again, use the relationship, which is already the active relationship, but this does not harm. And with that approach, I can also have just one line chart. We also draw the order quantity and the ship quantity. As we have two different measures, I could have two different measures in one chart and see then the different behavior of my orders and of my shipping quantities. If we use the other approach where I have two tables, so I add these tables 2 times, again, I would use maybe Power Query to load the same table several times. I could just duplicate it in DAX by creating a calculated table. Or of course, I would use Fuse. Fuse and Power Query maybe makes it much easier to rename the content of those, the column of those tables, because I want to make sure in the order date table, I have an order year, order month, and so on and so forth. And the ship date table, I want to have the ship year, the ship month, and so on. Not just a year or a month, because I want to avoid that I have 2 different columns in the same data model with the same name from different, but different meaning. So this model, I have now a order date and a ship date table, and one is filtering the order date column of the sales table, and the other one is the ship date column. And now here I have 2 independent filters. So I can now change independently my filter to the 2nd of June, which is filtering the order date, right, as I did previously. But I can also put a filter on the ship date now to tell I want to only see things which were shipped on the 3rd of July. So I can also influence the thing here. With that approach, I can only have one table, so one line chart. So I cannot put 2 different, like the order date by the quantity by order date and the quantity by ship date on one column. I can have like a hierarchy where I change between those 2. That's possible. But what's possible is to have a matrix where I put then my order date in here on the rows and my ship date on the columns. And then I can also see that like there were order on 1st of June, which was shipped on 3rd of July. There were another order on 2nd of June, which was also shipped on 3rd of July. This is possible with those multiple table approach. So let's come back to the slide deck. Here's the slide deck. So the takeaways here, to sum this up right in time, is you should take care of your data model. How you model your data does really influence how your data is shown in the visuals, how filters are applied, and if you want to change it later, it might break or change your reports, your behavior of your reports, or even change them. So it's very important that you get it right on the first try, so to say. And in many cases, you can exchange complexity between the model with complexity in DAX, as we've seen with the reuse relationship, or just having two tables in your data model. So with that said, are there any questions? So there's a link list, takeaways link list. And we talked about the relationships, the normalizing and denormalizing, and the consequences of that, and as an example about the data dimension. So a shape data model is really good because your visuals and DAX will like it. And ad hoc data model will just take all the tables or the data sources you have, Excel, whatever, and just put it into Power BI. Yes, it will work, but your visuals and your DAX formulas will much more like having a shaped data model. Any questions? Satya, still there?
Yeah. Looks like there are no questions so far. There was only one question regarding recording, so we will share the recordings afterwards. You will get an email. All the attendees will get an email with the recording and resources. Other than that, if you have any technical questions, I request all the audience to post your questions in the Q&A panel. And also, there is a feedback link in the chat window, friends, for all of you. So if you please, we request all of you to go ahead and give the feedback on the LinkedIn link that I've given in the chat window. So our speakers will really get motivated to come back and deliver more sessions if they get good feedback or whatever you feel about this session. Feedback is very important, friends. So you can ask your questions in the chat window, and also all of you can go through the data platform geeks.com website and go through all the precons that are available at this moment. And I'll also request Markus to take 2 minutes to discuss about what he's going to cover in his precon in September.
Yeah, sure. I mean, what we just talked about, this is a teaser for what I do in an 8-hour workshop. So we talked about some important stuff, or the very important stuff here in this talk. If you're interested in more things about that, I will use 8 hours to, on the one hand, to start a bit earlier. So we will also talk about what are tables, what are foreign keys, take a little bit more time about that, because I see that many people who are using Power BI, they're of course coming from a domain knowledge, they're domain experts, but that are not IT folks. So they never heard about what's a table, what's a foreign key, what's a relationship. So I will start at this point. So very like what I think in the very beginning, introducing all those important things. I also, of course, I will do recap and talk about things which I talked today. Take a little bit more time, on the demos to make it easier to grab. And then towards the end, we will have a lot of use cases. So while I start at really what I think at the very beginner level, so if you know knowledge about relationships or data modeling and so on, the first part will be of interest for you. Maybe it's also a refresher for you if you heard about that, but it's a long time ago. And towards the end, so in the second 4 hours, I will talk a lot of real world examples. So challenges I had in projects and how I solved them. So for example, budget, because the budget is on a different crane, on a different detail level, right? Because the budget is not on daily level. The budget is not on customer level. The budget is not on product level, but maybe on product group level. So how can we model and solve this? I will also talk about a solution I did for a customer of mine with multilingual reports. So that where the end user, the report user can change the language he or she wants to see the report. We will also talk about key value pairs. So sometimes you get the data delivered in just one flat table with two columns, a key, name, sales, quantity, whatever, and then the attribute values. So there's then a name in it, or there's a birth date in it, and so on. And how can we model and make use of that kind of models? And we also talk about composite models, which are still in, I mean, they're not in preview. The composite model is available currently if you want to mix loaded data and direct query data. But what's still in preview is this direct query capabilities to analysis services tabular and also to Power BI models. So the IT took care about your data model and publish this as a Power BI desktop model or as a Power BI data set on the workspace, or as an analysis services tabular model. And then you want to like include the budget you're working on, which is an Excel spreadsheet, right, and combine it with the data from the enterprise data warehouse. So this will be much more common for end users, for domain experts to add things to an existing model. And then it's also very important to know how you can include this without paying too much of a performance penalty. So I hope this makes you interested in my 8-hour class, and would be happy to see you there. And of course, answer your question right now, if there are any.
Yeah, that was a great preview about what we are going to get in the 8-hour class in September. And there is one question in the Q&A panel, Marcus. Why many-to-many relationships are bad?
Many-to-many relationship, they're bad because first of thing, if you really have a many-to-many relationship, it might make sense, but for many occasions I see it's just a data quality issue. So for example, you have a customer list and there's one customer key or many customer keys are duplicated in there. So this is showing you a data quality issue. And if you just say, okay, it's a many-to-many, I don't care. You will not discover or think well enough about that there might be a data quality issue. That's the one thing. Second thing is, yes, there might be situations where you need a many-to-many relationship, but even in there, I would model it with a bridge table in between. So a distinct list of values where I then have one-to-many relationships from this bridge table to the other bridge tables, because for the most situations, I mean, there is exclusions, and I will talk about that in my 8-hour class, but for the most situations, the many-to-many comes with a performance penalty. So your report might be slow. That's the thing. So performance and maybe data quality issue.
Yeah, so that's the
Does this answer your question? Mm-hmm.
That's the only question we have got, Marcus. So thank you.
Yeah,
Thank you again for taking out time from your busy schedule and delivering a webinar for Data Platform Geeks audience.
Sure.
Yeah, and we request all the attendees to go ahead and browse more about Markus Precon on dataplatformvirtualsummit.com. The link is available in the chat window. And also request all of you to go ahead and post your feedback in the LinkedIn post I have shared in the chat. So with this, friends, we are done for today. So see you soon next week. And hopefully, let's meet in the Precon
Bye, everybody.
In September. Thank you, Marcus.
Sure. Bye-bye.
Bye.